Welcome back to Smith Coding and Design. Today we are going to go through some of the drill operations for our GoPro mount. So we're going to jump right in and go into our spot drilling operation. So we're going to go to drilling. I'm going to go into my Toolpaths library and I'm going to select a 1/4 inch 140 degree spot drill. Now remember that 140 degrees because here in a minute we're going to jump over to PowerPoint and do some basic trigonometry, so you want to remember that 140 degree angle. So we'll select that, we'll select OK. So we're going 5,000 RPM and we are plunging down at 13 inches per minute. We'll go to geometry and then we'll go ahead and select our hole. Now our heights tab is going to be very important. So we want to make sure we are at our top height is a hole top. However, we will crash if we leave it at hole bottom. So this is a spot drill. We want to make sure we check hole top, and then we are going to go down minus 45 thousandths. And we will get into why we're going down 45 thousandths here in just a second. Okay, so that should be fine. And our cycle, we're just doing a drilling with a rapid out. So we'll click OK. And now what I will do is go ahead and simulate. This will be very quick. We go down, we perform our spot, and then we go out. All right, so that's good. So what I'm going to do now is hop over to PowerPoint. All right, so why did I go down into the stock 45 thousandths? So the first assumption I'm going to make is that, so we are making a 1/4 20 hole. So I'm going to assume the diameter of our hole is going to be 1/4 of an inch, which just happens to be the same diameter of our carbide spot drill. So I want to put the entire tip of the drill into the material. And so to do that, I need to find the height here, which is what I have labeled as X. And so to do that, we're going to use some basic trigonometry. So you notice I have a line splitting the angle or the tip of the drill in two. Remember I said our drill point angle was 140 degrees. So if we split that angle in two, half of it is 70 degrees. We know from basic properties of triangles that all of the angles inside must add up to 180 degrees. So if we have 70, we have 90, and then we have 20, that is our 180 degrees. The next thing we need to remember is basic trigonometry. And so if you remember SOHCAHTOA, the tangent of the angle 20 degrees would be equal to the opposite side over the adjacent side, which is our 1/8 of an inch or 125 thousandths. How did we get that number? Well, that again, we split this drill in two, so that is just half the diameter of the drill, which is the radius, or here 125 thousandths. So if we put that again in the equation where the tangent of the angle is equal to the opposite over adjacent, as I have shown here, we just multiply the tangent of 20 by 1/8 of an inch or 125 thousandths, and that gives us our X value, or the depth we want to go, at approximately 45 thousandths, and I did round that down. So that means for the tip of the drill to be completely in the material, we need to go down below the surface 45 thousandths. Okay, so now we'll jump back into Fusion and continue on with our drilling operations. All right, so now what we're going to want to do is drill all the way through our part and then through the bottom of our stock. And so to do this, I'm going to go for another drilling operation. And I am going to select my tool. So I'm going to go to my Toolpaths library and select a Go drill that is 201 thousandths in diameter. So I'm going to click OK. We're going 4,000 RPM and we're plunging down at 15 inches per minute. We'll go to our geometry and select our hole. We'll go to our heights tab. Again, our heights tab is very important. So we want to start at the top of the hole and we want to finish not at the bottom of the hole, but at the bottom of the stock. So we'll select stock bottom. And now what we also want to do is go ahead and put the tip of the drill through the bottom of our stock. So we'll hover over that so you can see what I mean. So we'll select that. And then I'm actually going to add a breakthrough distance of 50 thousandths just to make sure that our drill point does indeed go all the way through the bottom of the stock. So I'll go ahead and do that. And then I will select OK after I go through the cycle. And we want to use a deep drilling with a full retract. I'm going to round the pecking depth to 50 thousandths, and I'm just going to set the minimum pecking depth to 30 thousandths. I'm going to click OK. And then what we'll do is we'll go ahead and simulate. And I will go to the right side here. And what I'm going to do is actually just use the timeline to make it easier to control. So you see we're pecking in the center of our part. And what we want to make sure is that we go all the way through the bottom of our stock. So let's see if that happens. There we go. So let's go back a little bit. There we broke through the bottom of our stock. And there we go, just a little deeper to get that breakthrough distance that we talked about. So I think our drilling operation there is fine. So we'll go ahead and exit. We'll go back to the home view. So what we're going to do next is go ahead and chamfer around the top of the hole. And so I guess what's important to specify before we jump into that chamfer path is why I chose 201 thousandths for the diameter of the drill. So what you want to do is go to a drill and tap guide. So I pulled one up here from the internet. And if we go to the 1/4 hole, we can see that our drill diameter is 201 thousandths, which is exactly what I used. So that's how you would determine the size of the drill that you would use. Okay, so now we'll go back to Fusion, and what we'll do is go ahead and do another drilling operation, but this one is going to be slightly interesting because instead of a drill, we're going to use a chamfer tool. So drilling operation, we're going to select our tool. We're going to go to the Toolpaths library, and you'll notice that our chamfer mills don't show up here. And so all we need to do is go to tool category, and instead of hole making, go ahead and choose milling. And then we will find our 3/8 inch 45-degree chamfer. Again, we want to put a chamfer on our 1/4 inch hole. All right. So we want our diameter of that chamfer to be wider than our hole. So we're going to use a 3/8 inch chamfer mill. So I will select OK. 4,000 RPM, 13 inches a minute. That's fine. We'll go to geometry. All right. And the next thing I'm going to do is go to heights. Again, this is important. We don't want to crash into our stock. So we're going to use hole top. And for a bottom height, we're going to use hole top again. And for offset, we're going to use minus 130 thousandths. And I will explain that in detail again in just a minute. But because the angle at the tip of our chamfer mill is 90 degrees, we can use a special property of a 45 degree 90 right triangle. And so what happens is if we go down half the diameter of the hole that we want to create, we will essentially be flush with the diameter of that hole. So for example, if we wanted our point to be flush with a 1/4 inch hole, we would just go down 1/8 of an inch. So really, if I wanted the chamfer mill to be flush with our 1/4 inch tool, all I would have to do is go half of the diameter or the radius down, and we'll see that in detail here in a minute, and that would be flush with the diameter of our hole, but I'm going to go a little below that just to give us the chamfer. So I'm going 130 thousandths. And again, I'm going to explain that into detail here in just a second. That way nobody's confused. And again, we're just going to drill and wrap it out. So I'll press OK. And we'll go ahead and simulate, and the simulation is going to go fast. It's going to look identical to our spot drill. So we're just going to go down and out. There we go. And there you see it. We just sort of chamfered the hole. So we're going to exit the simulation, and then we'll jump over in PowerPoint, and I'll explain again why we chose the depth that we chose using the 90-degree chamfer tool. Okay. All right, so again, we're going to do some basic trigonometry. So the difference this time is that our tool is bigger than our hole. So if we look at how our drill point is entering the stock, we're not going all the way down. We're not putting the entire drill point into the stock. So again, we're assuming our 1/4-20 hole is going to be a 1/4 inch in diameter, right? And so if we split the drill point angle again, half of the diameter of our 1/4 inch hole would just be, again, 1/8 of an inch, or 125 thousandths, which I have drawn here. And so what we want to do is find the depth to go down with our chamfer tool that is now a 90-degree angle instead of 140 degrees. And so we're going to do the same thing. So half the diameter of the hole, or the radius, is 125 thousandths. We're going to use basic trigonometry. So we split our 90-degree angle in two, right, with the center line. So we have 45 degrees here, 45 degrees here, plus the 90 degrees gives us our 180 degrees. So all of our angles add up to 180 degrees. We're going to use SOHCAHTOA, or we're going to say the tangent of 45 is equal to the opposite over the adjacent, right? We're interested in this depth here, which I have as x, which is the opposite. So if we multiply the tan of 45 by 125 thousandths, we get that depth, which turns out to be the radius of the circle, or 125 thousandths, and that is because the tan of 45 is 1. So a lot of people like using the 90-degree chamfer mills, and you'll even see some people use 90-degree chamfer mills as a spot drill, because the math is easy. You know, you just need to go down half the diameter of the hole to really just get the tip all the way into the material, right, to match the diameter of your hole. And so what I did is I went down, you know, just a little further of that to make sure I got a chamfer on the edge of the material. So I went 130 thousandths instead of 125 thousandths. So that's why I went the depth that I went. So we'll go ahead and go back to Fusion 360 now. And so now what we'll do is we'll go ahead and chamfer the pockets and around the outside of our part. And so what I wanted to do to kind of, again, emphasize putting the chamfer here, if you want to just toggle back and forth between the drilling operation and the chamfer and just look at the stock, you can see that chamfer being done. Sometimes it's easier to just toggle back and forth between the stock just to see what's happening without going through simulation. So that's just an easy trick if you're, you want to make sure that you really did put a chamfer on your hole. You can just toggle back and forth between two tool paths and see how the stock changes. So now what I'm going to do is just go to 2D, and we're going to, again, just go to a chamfer. So we're going to click 2D chamfer. We'll go select our tool. We're going to use the same 3/8 inch chamfer mill. So again, let me find it. There it is. We're going to select it. and we are at 4,000 RPM, 20 inches per minute. That gives us right at around 1.25 thousandths per tooth. We'll go into our geometry. I'm going to select the contour around the top of the part, and I'm also going to select the contour around all of the pockets. We'll go to heights. Again, we've already removed all the material off the top of our part, so I want to be at model top, and I want our retract height to just be our feed height. So that's all good. And the next thing I'm going to do is go ahead and choose a chamfer width. I like using 15 thousandths, so that's what I use. You can choose whatever makes you happy. You could use 10 thousandths, 5 thousandths, doesn't matter. I'm using 15 thousandths for this part. It's not critical. All right, I'm going to use smoothing and feed optimization. We'll now go into linking. And I like coming in at a lead-in sweep angle of 45 degrees. Again, just a user preference. I'm going to click OK. And now we'll just go ahead and simulate this toolpath. So right-click and simulate. And again, I'm just going to move the timeline just because it's easier for me to control and show you guys what's happening. Awesome. So we're just going around and chamfering the part. And now we're just finishing up those pockets. All right, that all looks good to me. So I'm going to go ahead and exit. And that does it for this tutorial. So again, we went through the drilling operations, and then we went ahead and chamfered our part. So in the next tutorial, we will go over the thread milling. All right, thanks for tuning in. Please like and subscribe. All right, so we'll jump right in with the spot drilling operation. Then we'll switch to a Kinemetal Go drill and do the deep drilling with full retract, where we peck our way all the way through the part and through the stock. I like Kinemetal Go drills, or really any drill that I can hold with a collet and a tool holder. I am not a big fan of the drilling chucks, so I prefer not to use them. Now we're going to use the chamfer mill, chamfer the top of the hole, and then chamfer the pockets and the rest of the part. So that does it. Please go ahead and enjoy the Tormach finishing the chamfer path. Thanks everyone for tuning in.